everyone, welcome back to Coding Shinobi. In today's video, we will be solving the LeetCode problem longest common prefix. This is commonly asked question in the interviews. We'll break it down step by step and implement an efficient solution in Java. Let's first understand the problem statement. Write a function to find the longest common prefix amongst an array of strings. You are given an array of strings and you have to return the longest common prefix shared by all the strings. If there is none, return an empty string. Let's look at the given examples. So you are given an array of strings like this is your input, flower, flow, flight. As you can see, FL is common in all the strings. So FL is the common prefix. Note that the problem statement is asking you to find the prefix. Those who don't know, prefix is a letter or group of letter at the beginning of the string. So we are only interested from the start of the string. Let's take another example. If the question was common substring, then answer would have been different. Here, if it was a common substring in all the strings, the answer would have been ACK, as you can see. But since we have been asked the longest common prefix, we just need to check from the start of every string that we have given and whatever is the common element from the beginning of the string in the array of strings, we have to return that. What will be the answer for this example now? It would be an empty string. Since F is not equal to J is not equal to B, whatever. Like first character itself is not matching, so we don't have anything in the common in all the substrings. So we return an empty string from here. For more clarification, let's consider this another example given by the LeetCode itself. We have this input dog, race car, car. As you can see, the first character from each of the string is not matching. That's why the output here is again the empty string. There is no common prefix among the input strings. What if the input was like something like this? The first letter of dog and dig are same, but the first letter of car is not equal to the first letter of dog and dig. That's why this will also return an empty string. I hope you have understood the problem statement. Let's move on to the solutions now. Let's first discuss the basic brute force approach. For the brute force approach, let's assume flower is our prefix. This whole word flower is our prefix in the beginning. Since flower will be the prefix of the word itself, we will start checking from the next element in the string array. We will start from index 1. We will check if flower is prefix of flow or not. Is flower prefix of flow? No. Why flower isn't prefix of flow? All four letters of flower matches with all four letters of flow, but ER is not matching with this flow. That's why flower is not prefix of flow. If flower is not prefix of flow, then what do? We reduce the string by one character from the end. Why are we reducing from the end? Since we are finding the longest prefix and we know that the end characters may not be a match, we are just interested in the beginning part of the string. So let's reduce our string to flower. Now we'll check if this is an prefix of flow or not. Is flower prefix of flow or not? No, flow is not a prefix of flow. So tell me guys, if flow is not prefix of flow, should we check that if this word is prefix of flight or not? Since it is not matching for the second word itself, then there is no point in checking for the other words, right? So we will just reduce the character again from the end and check for the prefixes. Now we have flow. We reduced the character by from the end. Let's check if flow is a prefix of flow or not. Yes, all four character matches with flow. Is flow prefix of flight or not? FL matches, but OW does not matches with the flight, so no. Flow is not a prefix of flight. In this case, we again reduce our prefix by one character from the end. So guys, tell me if flow is a prefix of flow, then is it necessary to check all the reduced characters or all the reduced prefixes from flow with the same word or not? No, it is not necessary, right? So we can directly start checking from the next word itself. So we'll check if FLO is a prefix of flight or not. Is FLO prefix of flight? No. Then again we reduce this character by one more letter. Now, FL is prefix of flight or not? Yes, it is. And since there is no more words to check against this flow, we just return FL from here itself. If this prefix was not found and there were no common characters between, there was no common prefix between these words, then we would have reduced this prefix till an empty string and we just have returned this empty string from. Let's write the pseudocode for this brute force. We have this method string longest common prefix, an array of string. I'll handle the edge cases like if the strs empty or null. And in the edge cases here, if this is empty or if this is null, then we just need to return empty string from here itself because empty string matches with anything, right? Let's take the first string as prefix. I will iterate through all the words now. From the next word, right? We don't need to consider the first word again because it is going to match to it itself anyways. We will check if that prefix matches with the string or not. If the prefix does not match, then we are going to reduce it by one character using substring method. What if my prefix becomes empty while reducing the character by one? In this case, we need to return an empty string. And in the end, we'll just return the prefix. This is the main logic where we are checking if that word includes its prefix or not. So if we're checking flow in flower, it will return the index as 0 here. As long as we are not getting our prefix, I am just reducing the prefix string by one character. Since this is the brute force approach, we will not discuss the code in detail. Just have a look and try to understand what is written in this code. But let's discuss the time complexity here. For this loop, strs.length, let's call n, which will be the number of strings given in our array. And let's say m is the length of a single string. And how many times we are going to compare? We will compare up to the smallest string in the array, right? So this logic, this n time loops is going to run, and for n times we are going to execute this loop for m characters, right? So the time complexity becomes big of n cross m. The space complexity will be big of m because we are using the string prefix, and let's assume our space complexity is big of m. The space complexity could be even n cross m in the worst scenario because for this n times we are going to create the strings in the string pool. But let's just assume that we are using this prefix string externally to store this in our code. Our space complexity is going to be big of n, though we are just interested in the time complexity here. Now let's discuss the optimized approach. In the previous approach, we were comparing full words, hence making more unnecessary comparisons, right? In this approach, we compare column by column. Let's understand this by example. Let's take the same example again. We'll start from the first character of first word, which is F from flower. For every string in the array, check if F matches with the first character of other strings or not. So we have this character C is equal to F as of now with us. We're going to check if F is the first character of the string or not. Yes, F is the first character. So we have F as the potential answer. Now, since F matches with all the characters, we will move on to the second character now, which is L. Now, L is our next character, right? We will check L at this position on every string with the same position itself. Like we have this L is at first position. For first position in every string, we'll check if L is present or not. For flow, L is present. For flight, L is present. That's why our potential prefix will become FL now. If the character matches with every character in every string in the given string array at the same position, then we move on to the next character. If a mismatch occurs, then we just return the prefix that we have found so far. Up the next character is O. Next character is O. Does O matches with O? Yes. Does O match with I or not? It does not. So we just return the prefix that we have found so far, which is FL in this case. Let's first look at the pseudocode and then we will dry run on few more test cases. Again, we are going to handle the edge cases. We will see the full working code when we are actually writing the code in the LeetCode platform, LeetCode editor. We just assume that we are handling the edge cases here. Now, as per our approach, we are going to iterate through the first word and have the checks against or against the first word. Then we are just extracting the character at ith position using char at method of string. And then we are going to make the checks for all the words at that particular position I. And this is going to be the main condition. If my I becomes greater than word ka length or the character does not match with the character that we are looking for right now, checking against right now, then only I'm going to return my prefix from here itself. How I can do that? Strs of 0 dot substring 0 to I. And in the end, I'm going to return. If this is never executed, let's safely assume that the whole word is the substring. Let's run this against some test cases. Like, first we will consider if it can work for a single word or not. Let's assume like we have this word itself. We have only single word in our array. We have this strs of 0 as word. This character is now w. But when we come to this loop, strs dot length, what is strs dot length in this case? It is 1. Is it 1 is less than 1? No. So this loop is not at all executed for any word. So in this case, this condition is never executed and we will just return the first word of the array. So our solution will work for the single word as well. Next test case to consider is like we have an empty string in our array. In this case, this first for loop only will not get executed. Since what is the strs of 0 dot length, which will be 0. So 0 is not less than 0. So this loop will not get executed. And in this case, we will return the first word in the array, which is an empty string. So our solution works for the empty strings as well. What if this was vice versa, like hello is come first and then we have this empty string? What will happen in this case? The first word is hello. The first character is H. And now the second word, which will be an empty string here. My I is 0 in this case. What is my word dot length? My word dot length is 0 here as well. Is word dot I is greater than equal to 0, then strs dot substring of 0 comma I. What it will return? Str of 0 is hello dot substring of 0 comma 0. It will return as an empty string. So this test case is also been handled by our code. For the third test case, let's assume that we have all similar words. All words in our array are similar. What will happen in this case? Our strs of 0 will be triple A. Our C character will be A. And our word will be again triple A. Which will be this word? strs of J, which is the first, the word at the first index. Is this condition true in our case? I is 0, word dot length is 3. Is I greater 0 greater than 3? No. And word dot caret I is not equal to C. Word dot caret I, what is it? Word is A. Caret I, which is caret 0, which means A itself. Is A not equal to A? So this condition does not satisfy. So we move on to the next character. Next word now. What is the word? What is the next word now? At the index 2, J is incremented. We have triple A against again in as a word. Now again, this condition is not satisfied. And also this condition is not satisfied because A is equal to A. Again, what in this case we have completed this in inner loop. In this case, I will be implemented now. Now I will become 1. What is the character at the first index of this word, which is A again. And same thing will be repeated again for another two words. This if condition is never executed and we will return the result from here itself. So guys, I hope you have understood this approach. Let's discuss the time complexity of this approach again. What is this SGRS of 0 dot length? Let's assume it is of length m. And as we know, STRS dot length, strings dot length, which is going to be n, which is number of strings in our string array. So this loop is going to run for m times. This n loop is going to run for m times. So our time complexity is bigger of m cross n, which is equivalent to n cross m. Now, guys, you are probably wondering, like the earlier approach, the brute force approach was also n cross m, and this approach is also n cross m. So what different we are doing? As you can as you can see, we are just comparing the characters, and there are very less comparisons. Like the comparisons are equivalent to the length of prefix into the length of strings, like length of prefix into length of string array. There are very less comparisons as that we have seen in brute force. If you look at the brute force approach, this index of method, what do you think it does internally? It will check character by character if the substring is matched or not. If the substring is matched, then only it will return the value, right? So there are like many comparisons involved here in this approach, and we are optimizing it in our solution. In our solution. Now, guys, let's code this out. Write the code and run it on LeetCode. And let's see the output of this code.
First, we are going to handle the edge cases, which are like in case our given string array is null or given string array is empty. In this case, our answer is an empty string. Now we are going to iterate on the first word. Let's check the let's compare the character vertically for every other word in the string array. Now if my I is greater than word ka length, or if my character does not matches with the character that we are trying to compare, here I'm straight away returning whatever prefix that we have found so far. In the end, I'm going to return the first word as the prefix. Let's run this program. Okay, the basic test cases have been passed. Let's submit this. Okay, the solution has been accepted. So fellas, that's it for today's video. We discussed two approaches for solving the longest common prefix. Both the approach had the same type of complexity, but the second one is more optimized because we are doing less comparisons as that we have seen in the brute force approach. And also the n cross m solution works because if you look at the constraints, you can see like the strs.length is only 200, and the length of array is also up to 200. So 200 into 200, like whatever it comes out to be, like 10 raised to 4. So our solution should work, n cross m solution should work for this input. And again, if you found this video helpful, give it a like and subscribe to Coding Shinobi for more coding tutorials. Comment below if you have any questions. Keep practicing, keep coding, and I'll see you in the next video. Bye bye.